Hello students, welcome back to my channel Infinity Minds where maths is made easy. Today we shall be taking up the last two questions, question number 10 and question number 11 of the chapter Quadrilaterals. Okay, it is there on page 108 and 109 as figure it out. So let us begin. Question number 10 says, will the sum of the angles of a quadrilateral such as the following one also be 360 degree? Find the answer using geometric reasoning as well as by constructing this figure and measuring. Okay, so in this diagram, this diagonal BD I have joined. The diagram shared in the textbook is of this kind. Okay. It is trying to ask you that if it isn't the regular quadrilateral that you have, yes, such quadrilaterals are called concave quadrilateral. Okay, see, I'll just show you the ones in which you observe a reflex angle coming is called a concave quadrilateral. In the earlier syllabus, we used to discuss this. Now, as such, in Ganita Prakash, this has not been emphasized. The regular quadrilaterals that we do, where you have each of the angle to be as an acute, you can say, or the ones which aren't, none of them would be reflex. Another way to determine is joining of opposite vertices. So one of the diagonals, joining of opposite vertices, is always called a diagonal. One of the diagonals falls outside the quadrilateral. Such quadrilaterals are referred to as concave. As far as coming to the degree measure, so one of the angles to be reflex, the one which is more than 180 degrees is there. Yes, for that also would the angle sum property of a regular quadrilateral be same? Well, yes, in that case, of course, when we studied the property, we never got into types of quadrilaterals. These are the two types that I discussed with you, okay? So, but as such, there is no reference, especially in this chapter now, the syllabus that you have. So, it doesn't have any role. For you, it is simply a question asked that will it have? Okay, let us join it via diagonal. In the given quadrilateral, join BD. So, we get two triangles where this particular, now see, this is what I have been talking about on and off. Let me further explain it. Now in this quadrilateral ABCD, vertex A and vertex C, the angles which are being made at these points are independent. These angles are not getting split into any of the further parts. But as far as angle B is concerned, it is getting split into two of them. So if calling it just as angle B is not sufficient, here it is essential to give it a three-letter name like angle ABD, and the other one would be angle CBD. I have observed many students not to be clear of where to use which one. Here, in the case of angle A, you have the freedom to call it simply angle A. There is no other part. Angle A isn't getting split over into any other part. But for angle B, if you just call it angle B or this part, left part, right part, side of angle B, no. That's not the way one denotes an angle mathematically. You must call it angle ABD and CBD to be precise. In order to save our time and effort, for quick versions, we use number values. We give number names to the angles. Like in this case, I have given them, say, angle number 3 and 4. And similarly, at vertex D, also the angle is getting split into two parts, angle ADB and CDB. So I shall give them also number names. See, I have given them angle 1 and 2. And here I call them 3 and 4 and angle A and C. Okay, all this till now what I have discussed is in general for your help. Students who study from Infinity Minds, their concepts should be completely clear. Coming to this triangle, angle sum property for a triangle talks about that the total of the three angles would be 180 degrees. So here angle A plus angle 3 and angle 1. Coming from this triangle ABD, total will be 180. And similarly, one of the diagonals is able to divide the quadrilateral into two triangles. Each triangle angle sum is going to be 180 degrees. Simple as that. We are basically trying to put that into words. The first triangle, it is A plus 1 plus 3. And from the second triangle, it will be C plus 4 plus 2. So two 180 degrees getting added to give you a total of 360 degrees, children. Of which angle 3 plus angle 4 shall naturally make up to angle B, and 1 plus 2 shall become angle D. So A plus B plus C plus D, yes, sum of the four angles of the quadrilateral is 360 degrees. This is by reasoning. Mathematical reasoning is what is important. And by measuring, for measuring you put your protractor and measure and check individually. In that case you won't be joining BD, children. You would simply be measuring the value of angle A. Angle D would be taken, this complete angle D reflects angle B and angle C. You can practically measure with the protractor and check. Yes, the total shall come out to be 360 degrees. Okay. So let me just sum up. As I had explained much in detail, any quadrilateral divided via one of the diagonals, it gets divided into two triangles. Each triangle's angle sum property 180 degrees each adds up to give you a total of 360 degrees. 1, 2, 3, 1. In total, there would be 6 angles. You can pick up any quadrilateral in general. Even the one that we have been doing in the beginning, this proof has been shared with you. So sorry, you'll be joining it via one of the diagonals. So 1, 2, 3 angles coming from one triangle, another one coming from another set of 3. So total of 6 angles coming, giving you 360 degrees, 180 plus 180. I hope it is clear. It's a very simple question to go about. Okay. So let's go to the next one. Last question of the exercise, true and false. But it also talks about justify your answers. So all the statements that are taken from Ganita Prakash have been put into these boxes, and I've written answers beyond after that with reasons. Let's go through them. Taking a reading itself alone would be helpful, I believe, for you. All of this has been explained very clearly throughout the chapter, children. And the best explanation can be found in the very first intro video of this chapter. The intro video is very important and useful that I've been emphasizing on and off. Okay, coming to the first statement, a quadrilateral whose diagonals are equal and bisect, most of them you would find around properties, children. Most of them surrounding around properties only. You have to solve. Properties help you to decide whether a given statement is true or not. Okay, let's go through. A quadrilateral whose diagonals are equal and bisect each other must be a square. Well, diagonals of a square are equal and they certainly bisect. But what else? Is it alone sufficient? Equal and bisect can be true even for the case of a rectangle. For example, even in a rectangle, diagonals are equal and they bisect. So, will that be sufficient? No. Well, there could be different ways of whenever justification is asked, it depends how you justify. Like one of the ways to justify could be to give where these conditions are true, still not being a square. A diagram, a figure where these aspects are true but is not a square, that could be one valid reasoning given, justification given. The other could be you talk about square. Well, for something to be a square, it's not just sufficient for diagonals to be equal and bisect, but they should be perpendicular as well to each other. Perpendicular bisector is what we look at. Okay, so square will not be correct, so it's an incomplete, insufficient. You must have it to be perpendicular. Condition also should be given to you. I hope that is clear. Moving to the second statement. A quadrilateral having 3 right angles must be a rectangle. Well, yes, rectangle as in needs to have all the 4 angles to be 90 degrees. But if you have 3 of them fixed, the fourth is bound to be 90. Can anyone think of why? Because of the angle sum property. Angle sum property, children. The total has to be 360. If 3 have already occupied their places to be 90 each, 90 into 3, 270. Get subtracting it from 360. we get in 90 degrees only. Okay, yes, of course, that is true. Point number 3. Statement number 3, a quadrilateral whose diagonals bisect each other must be a parallelogram. Oh, well, yes. If you say rectangle, square, rhombus, go back and visit to the intro video, all of them fall under parallelogram. There used to be that big Venn diagram in which all of them fall. Of course, they can be further rectangle and so on, but it won't be wrong to call it a parallelogram. They all come under the head of parallelogram branch. Yeah. Going to the next point. Statement number 4. A quadrilateral whose diagonals are perpendicular to each other must be a rhombus. False. It may be a kite also. I think that is sufficient enough. Completely, entirely, they are based on your properties, your knowledge that you've gained. Definitions, properties of types of quadrilaterals. Okay. Point number 5. A quadrilateral in which opposite angles are equal must be a parallelogram. Well, yes. If we talk about type of parallelogram, then further you need to think. Parallelogram, it's okay. It's not wrong to call it a parallelogram. That is absolutely okay. Further type is asked, maybe you require more points. You require more facts with you to be able to tell about exact type. Parallelogram is a broader name in itself. Yes, that's very much true. Statement number 6, a quadrilateral in which all the angles are equal is a rectangle. Yes, very same can work for a square also, children. These equality of angles, that 90 degree which we were studying, 3 angles are 90, the fourth will be 90. Yes, all that would be true for the case of a square also. Yes, it's very much true. Isosceles trapeziums are parallelograms. No, nothing like this. Isosceles only talks about non-parallel sides equality. It has nothing to do with parallelogram. The opposite sides have to be parallel. It doesn't make it to be parallel. It is about equality, not the pair becomes parallel. False, the other opposite side may not be parallel. Okay, that's about all. So we come to the end of the chapter. See you soon with another chapter. Till then, keep practicing. Do like and subscribe to my video. Subscribe to my channel. And keep practicing. Put your doubts in the comment section. Okay, thank you everyone. All the best.